Hello everyone, welcome back. I wanted to do a follow-up video to my last video on the RC2014. The RC2014 is a Z80 based kit microcomputer, pays homage to the microcomputers of the 1970s and the 1980s. An incredibly neat device. I'm absolutely loving it. But in that video, I only went through the base system, the RC2014 Pro, and the cards and setup that you have in there. At the time I ordered it, I also ordered 4 other cards because I thought they looked interesting. And I wanted to go through those 4 cards in this video, show you how they're set up, because I had a couple little issues along the way, and show you how they work. So starting from over here, we have the ESP8266 Wi-Fi module. And it does exactly what it says. It allows you to connect your RC2014 wirelessly. Now, the way it's configured out of the box is that you'll be able to telnet into it. So you don't have to have your RC2014 connected via serial cable or an FTDI cable to your computer and firing up a terminal on your computer. You can simply telnet into it, and it can be completely standalone. Then we have, let's do this one next, the digital I/O module. And it provides you with 8 digital outputs and 8 digital inputs that you can access via BASIC or via assembly language. Then right here, we have the Raspberry Pi serial terminal, the Raspberry Pi Zero serial terminal module. And what it allows you to do is it allows you to connect your RC2014 via composite or via HDMI. It also allows you to connect a USB keyboard, and it essentially turns your RC2014 into a standalone computer. So once again, you don't have to connect it via a FTDI serial connection to your main computer. It gives you a complete standalone serial terminal. One thing to note, or actually 2 things to note, the Raspberry Pi on here has to be the Raspberry Pi non-wireless version, the non-wireless version of the Raspberry Pi Zero. The non-wireless version is a little bit rarer and a little bit harder to find. So make sure you get the non-wireless version. For example, mine right here is the most current version, I believe, Raspberry Pi Zero version 1.3. And then one other thing. If you're going to connect a USB keyboard to the Raspberry Pi serial terminal, you're going to need a USB OTG cable. Make sure it's an OTG cable, which stands for on the go. What it allows the Raspberry Pi to do, you plug it in right here on the USB slot, is it allows the Raspberry Pi to act as both a host and a device at the same time. Basically, it allows the Raspberry Pi to be both a master and a slave. All right, last card is 512K RAM, 512K ROM module. And what this allows it to do, it essentially has a ROM version of CPM80, I think version 2.2 on it, and quite a few other things. So let's go through. The first thing I want to do is I want to go through setting up the Raspberry Pi serial terminal card, and then we're going to talk about the wireless card. So let's head over to the computer. Okay. The first thing I wanted to go through with you is setting up the serial terminal card, the Raspberry Pi serial terminal card. I had a few issues when I started to use it. It comes with a micro SD card with what you need on it, and I was having a lot of trouble. The first bit of trouble I was having was getting a keyboard connected, and it turned out I thought that the USB hub that I had was an OTG hub, and it turned out it wasn't. So I ordered a cheap $5 OTG cable from Amazon for next day delivery. That fixed that issue. But then I was having lots of really just strange and bizarre issues. And so I started doing some research, and the way I fixed them was I basically installed the newest version of PiGFX, which is what the Raspberry Pi Zero uses to act as a serial terminal. It's basically a graphics package, a bare bones graphics package. You don't have to wait for the Raspberry Pi to boot up. It's almost immediate. So here's how you do that. What you're going to do is you're going to come to this GitHub repository, the PiGFX, and I will include a link down below for it. Then what you're going to do is you're going to come over here to code. You're going to click on code, and you're going to download the zip file. Once you have this zip file downloaded and you have it unzipped, you're going to be left with this PiGFX master. And inside of PiGFX master is this bin directory. You're going to take all of this, the kernel, kernel 7, kernel 8-32, the PiGFX text file, and this recovery 7. I don't know if that's an I or an L. Anyways, it doesn't matter. You're going to copy and paste all of them onto the micro SD card that came with the Raspberry Pi terminal. Now there's going to be two other files on that Raspberry Pi micro SD card. Let's see here. The other two files are bootcode.bin and start.elf. You want to make sure that those are kept intact. Don't lose those. In fact, before I started doing any of this, I backed up that Raspberry Pi micro SD card. So just in case I screwed things up, I could go back to where I started. But you need this bootcode.bin and this start.elf file. And once you have written all that to the micro SD card, pop it back in. Oh, nope. I'm sorry. There's one last thing you have to do. Once I got that in there, it started working a lot better, but I was having lots of bizarre issues. For example, when I'd go to run a directory command on CPM, it would only show me the very first file and then quit and drop me back to the prompt. And all sorts of other weird stuff. And so I started doing a little bit of investigation, and this PiGFX text file is a configuration document. Load it up into a text editor, and what you want to do, okay, it's right here. What you want to do is you want to set this replace line feed with CR equal to 1, and the send control line feed equal to 0. That's what did it for me. It might be different for you. Experiment around with this, but I believe that's the only two things I changed. Was I made send CR LF equal to 0 and replace line feed with carriage return equal to 1, and it all worked. So let's boot it up and show it in action. And there we go. We're good to go. Oh, one other thing. This RC2014 logo isn't displayed by default when you boot the serial terminal card. There's a option in that PiGFX configuration file that you can set to show the RC2014 logo if you want. Okay, so what I've got, I have the digital input and output card plugged in. We're going to test that while we're at it. I have the Raspberry Pi serial terminal. Right here, this right here is the OTG cable, the USB OTG cable. It goes to my super cheap USB keyboard. I have a HDMI cable run to my capture card. You can also do composite out right here, and I've tried it. Composite out looks great. In fact, I think it looks maybe even a little bit better. If you've got a HDMI screen, it may or may not stretch the terminal to match the width of the TV or monitor that you're on.
I have the 512K ROM, 512K RAM card plugged in, which, by the way, when you have this plugged in, you do not need to have your 64K RAM card plugged in, and you do not need to have your pageable ROM card. In fact, you need to take both those out in order for this to operate properly. So we've booted up, and it tells me that it is waiting for UART data. So what we're going to do is we're going to hit the reset button, and there we go. So we can boot a variety of systems, a couple types of basic, fourth, CPM, a monitor, a few other things. We're going to boot into CPM. And there we go. We're now in CPM. We got a D drive. See what's on that D drive. It's a far more complete CPM system than what's included on the pageable ROM module or the CF card that comes with the basic system. What I want to do, I want to come over here to the D drive. And on the D drive, there's a whole bunch of stuff. A couple versions of Microsoft Basic, SuperCalc, DBase 2, WordStar. You've got Zork 1, 2, and 3, and a whole bunch of other stuff. I have Microsoft Basic 85 installed, so I am going to go ahead. Well, let me show you what you got to do in case you want to unpackage some of these. So they're packaged up in a PKG file. If I'm not mistaken, D package is on my B drive. So I go B colon. Oh, we got D package right here on the D drive. So I don't even have to do that. DEPKG. And let's say I wanted to unpackage Microsoft Basic 80. mbasic80.pkg. And there we go. It's going to extract mbasic80. So we'll wait for that to finish. What we're going to do is we're going to take a look at the digital I/O card. All right, and we're done. I'm going to start up Microsoft Basic 85. Okay, you can get to the digital I/O card with a command called out, and it takes the port number, which, by the way, the port is configurable. I installed mine. You can't see this, but I put jumpers along there so I can change which port I can write and read from. It's default set to port 0, but I can switch these jumpers, and I've tried it out with port 0 and port 1. Works great. And I write a number to that port, and it will light up those particular LEDs. So, for example, if I write 255, it's of course going to turn all of them on. If I do out 0 and let's go with 64, it's gonna turn on the next to last digital output. And of course I can turn them all off. I can read it with the in port INP 0. And what I'm going to do, well, let's just do it without pressing anything. I get 0. But if I'm pressing a button, well, let's just press the first one. I should get a 1. And I do. Okay, let's take a look at a couple programs. Let's load, what do I call it? CountB.basic, I think. And that's exactly what I did. So all this does is just going to basically count in binary. It goes from 1 to 255, and it outputs that number to X. Does a little bit of a delay, which the user can set a delay. And then does the next one. I actually don't need lines 50 and 60. Oh, no. Now I remember what happened. So at the very end, after it's done counting, it'll wait for a second or so and then set everything to 0 and then exit. So let's run it. Well, let's do a delay of 50 and we should see it start to count. These LEDs are pretty bright, by the way. And so, yeah, it's counting in binary. And all done, and then it shuts off. Let's see here. Oh, I know. Let's load Cylon.exe. Cylon.bas. Okay, so what Cylon.bas does is it makes a little scanning thing going back and forth. And this is a modification of a program that was included in the documentation. And I'll link to all that below. I'll link to the GitHub account that you can get the latest version of PiGFX from, etc. below. If I forget, you know, just let me know. So it sets an initial delay for our delay loop of 150. And then basically goes from 0 to 7. Outputting to port 0. 2 raised to the power of F. So it's essentially going to light up one single LED at a time. Go sub 100. What I do down here, I actually use the import, the INP command. You can change the delay. If you are pressing button number 1, it's going to increase the delay. If you press button number 8, it's going to decrease the delay or speed up the scanning. And of course, I say if D is less than or equal to 0, then the delay equals 0 because we don't want it to go below 0. And this is just a little bit of debugging. I print the current delay. Then we delay for a bit and return and keep going. So let's run it. And so you can see it scanning back and forth there. And let's make it go faster. Faster. And we get all the way down to a delay of 0 and it won't go below 0. So that's pretty quick. And then we can slow it down. It's not a very good way to read the button only in that delay loop. When you start getting up here with really long delay times. So there we are. We're up to a delay of almost half a second. Speed it up a little bit. There we go. I like that delay right around that 150 range. Okay. And then the last one, I don't remember what I called it. Count binary, basic IO. Okay. And this is an incredibly simple program, and once again, it's in the documentation. All it does is it says out 0. So it's going to output to port 0 whatever the import on port 0 reads, and it just goes to 10. So all it's going to do, whatever button you're pressing, it's going to light up those buttons. It's basically writing the value of the output port to the input port. Or excuse me, the input port to the output port. Okay. So that demonstrates the Raspberry Pi serial terminal. It demonstrates the digital I/O card, and it demonstrates the ROM or the 512K RAM, 512K ROM card. I really like the Raspberry Pi serial terminal once I got it going. I don't like being tethered to a computer. I don't like. I really dislike having to use PuTTY to connect. So this thing's awesome. For the digital I/O card, I've got plans. I think I'm going to order another one. And instead of LEDs here, I'm going to put just some pin headers on the LEDs and where the buttons are, so that I can run some jumper wires off to a prototype card. And I'm really thinking about seeing if I can make a little RC2014 robot. Something simple, roams around, maybe senses some obstacles and that sort of stuff. All right, let's take a look at the ESP card, the wireless card, and I'll show you how I got that set up, because I had a little bit of issues with it also. So be back in a minute. I'm going to go through a little bit of configuration of the ESP8266 Wi-Fi card. I had a little bit of issues with this one, and I'll explain how I fixed them. So there's really good instructions on the RC2014 website for how to initially configure it. Essentially, once you start up the ESP8266 Wi-Fi card, it's going to turn into a base station. You're going to use your phone or your computer to connect to that base station. Now on this, it said that it would have, the base station would have ESP in its name, but mine did not. But it was pretty easy to find. It was the only unsecured SSID that I could find. And when I turned the RC2014 off, that base station disappeared. So it was easy to find. Anyways, you just connect to it and you go to this website right here, 192.168.4.1, and you're going to configure your ESP link. So here I am. I'm actually on my computer. By the way, I'll include a link to those instructions down below. So when you initially configure it, the first thing you're going to do is you're going to set the CON LED to GPIO4. That's the LED that shows that you have Wi-Fi connectivity, and then GPIO5 for the serial LED, and that's what's going to flash when it's sending and receiving serial data. And once you do that and you click Changed, you'll come over here to Wi-Fi station. I did all this on my phone. It was super simple. And on Wi-Fi station, you're going to select the network that you want to connect to and the Wi-Fi password. Hit connect. It'll take a couple minutes and connect. Then what you can do from then on out, like I've done up here, the IP address of my ESP8266 card is 192.168.86.40. It's going to be different most likely for you because it's going to depend upon your network. Just jump on your router or however else you use to, or whatever else you use to figure out what devices are on your network. The other thing that you can do is it will show you on that web page once you've connected what your IP address is, so you can just write that down. Okay, so I thought I was good to go. And then what I did is I opened up PuTTY, I connected that with a telnet session, and everything was good to go. I hit reset, got my text, and the problem was it wouldn't accept any text for me to input. Once I input text, it just all went to heck. Whole lot of troubleshooting. I figured out that it also would only work when I had the RC2014 Raspberry Pi serial terminal card plugged in, which I thought was a bizarre behavior. And so after some researching and a bunch of other stuff, I finally figured out that there's another configuration thing you need to do. This RX pull-up right here, receiver or receive pull-up, is initially configured to be on. That internal 40K pull-up is configured to be on. And that was messing things up. Turn that off. Click Change and save it. The other thing I did was I turned off the debug log. And I found this on a post on the internet, and I will link to that post also. I turned the debug log off. Some people were showing that they were getting debug output into their terminal. Once I did that, and I set PuTTY, so let's open up PuTTY here. I set PuTTY for a raw connection. So let me go through that. So to set PuTTY for raw connection, there's my IP address, port 23, and I click on raw. Over here in terminal, these are my settings, and make sure for local echo and local line editing you put those as force off. Keyboard, backspace key, control H, home and N keys standard, function keys, escape, whatever that is. Initial state of the cursor keys normal, and I think that's it. I will link once again to the post that I found these settings on. Okay, so now I'm going to click open. So notice I've got nothing. I'm going to hit the reset button, bam, there I am. I am back into CPM. It works great. Let me show you a little game. I think it's on the C drive. Yeah, we can play Snake. All right, the controls are really difficult. Z and X for left and up, and N and M for right and down. And you can see it works absolutely perfect. And it's basically Snake in a terminal. Ah, okay. And there's a little utility to clear the screen. Anyways, it works great. In fact, it works extremely well. Now, so now you can telnet into your RC2014 from just about anywhere. So I got all the cards working great. What I want to do with the ESP8266 card is install some different firmware, install a terminal for CPM, and see if I can't use it to connect to BBS's remotely online. The other thing I want to do with the digital I/O card, like I said, instead of installing the LEDs and the buttons, is install some pin headers so I can use some jumpers to jumper over to possibly a breadboard and turn this thing into a little roving robot with some external circuitry. I'm not a very good hardware person. I'm much more of a software person. I can do lots of simple stuff with digital electronics, microcontrollers, etc. So we'll see how well it works, or if I can get it done. Anyways, if you got any problems or any questions, just post down below. Thanks a lot, and don't forget to like and subscribe. Bye-bye.